Dear students, in my last lecture, I talked about calculus and its two basic goals. I also talked about limits, that is, limiting value of a function. Now today, I am going to talk about one of the fascinating concepts in calculus. That is, first topic of calculus mentioned in your NCERT textbook of class 12th. That is continuity or continuous function. Now, if we go through dictionary meaning of continuity, it is something which is uninterrupted or unbroken. And same is the case here. A function is said to be continuous if it has no holes or no cuts or no jumps or no asymptotes. To understand this, let us take a function y is equal to fx and we draw its graph. Now this point is also a part of this graph and there is a hole in the graph. Let this be at point A. Now let this point be at height m and the hole be at height L. Since part of this graph is at height m at point A, so therefore value of the function at A is equal to m. That is f of A is equal to m. Also, as we approach A from left, fx approaches the height L. That is, as limit x approach to A minus fx is equal to L. Similarly, if we approach A from right, fx approach to the same height L. So we can write limit x tends to A plus fx is equal to L. Thus, we can say that the limiting value, limit x tends to A, fx is equal to L. That is, limiting value of the function is equal to L. But value of function is equal to m at point A. So they are not equal. If this point were not here, if it were at this position, that is in the hole, then there would not have been any hole and this m would have been equal to L. That means limiting value and the value of function would have been equal. In that case, the function would have been continuous. This shows that if limiting value is equal to value of function at some point, then the function becomes continuous at that point. Okay, now let us take one more function, y is equal to fx. We draw its graph. Like this represents graph of this function. At point A, let this end of the graph be at height L, and this be at height M. Then value of function at A is equal to L. That is, f of A is equal to L. Also, as we approach A from left, fx approaches to this height L. That is, we can write limit x approach to A minus f of x is equal to L. And when we approach A from right, fx approach to the height M, that is limit x tends to A plus f of x is equal to M. Now this shows that the limiting value of the function at point A does not exist, as left hand limit is not equal to the right hand limit. This is also the reason that there is a jump in the graph at point A, which makes the function discontinuous. Now, we can say that for a function to be continuous at a point, left hand limit must be equal to the right hand limit, which in turn must be equal to the value of function. Then only we can say that the function is continuous at a given point. Okay. Now, in the previous case, the limiting value of the function exists. Also, the value of the function exists, but they were not equal to one another. So that was the reason that there was a hole in the graph which makes the function discontinuous at that point. So from all this, we conclude that a function is said to be continuous at a given point A if, number one, f of A exists. Number two, limit x tends to A, f of x exists. That is, value of function at the given point exists, and also the limiting value exists at that point. Number third, the limiting value must be equal to the value of function. Now, if both that is value of function and limiting value exists and they are equal to each other, then we can say that the function is continuous at that point. So that is the definition of continuity of a function at a given point. Okay, now let's take a function fx is equal to mod x by x. X is not equal to 0, and this is 0 when x is equal to 0. So let us check whether the function is continuous at 0 or not. At x is equal to 0, f of 0, when x is equal to 0, value of function is equal to 0. That is, f of 0 is equal to 0. Thus, value of function at x equal to 0 exists. Now let us find left hand limit and right hand limit. Limit x tends to 0 minus fx. That's left hand limit when we approach 0 from left. At that time, limit x tends to 0 minus mod x by x. We know that mod x is equal to x when x is greater or equal to 0, and this is equal to minus x when x is less than 0. Since we are approaching 0 from left, that is through those values which are less than 0, and less than 0, mod x is equal to minus x. So we can write limit x tends to 0, it is minus x divided by x. And x is not equal to 0, so that means minus x by x. X divided by x is 1, and it becomes minus 1. Now let us find right hand limit. 0 plus f of x, this is limit x tends to 0 plus mod x by x, that is, we are approaching 0 from right, that is through the values which are greater than 0 and very close to 0. So at that time, mod x is equal to x, so we can write limit x tends to 0, x divided by x, and x is not equal to 0, so x divided by x, that is 1. So in this case, it is 1. Now this shows that our left hand limit and right hand limit are not equal. So that implies limit x tends to 0 minus fx is not equal to limit x tends to 0 plus fx. Now here, the left hand limit exists and is equal to minus 1. Right hand limit exists and is equal to plus 1. So the two are not equal to one another. That is, left hand limit is not equal to right hand limit. This indicates that there is a jump in the function which makes it discontinuous at x is equal to 0. So let us draw its graph and find why there is a jump and why it is discontinuous. Now this is the graph of the function, and clearly there is a jump in the graph which makes it discontinuous. Now we will do many more questions related to continuity in our next lecture. Till then, take care of yourself. Thank you.